This lesson is going to be about writing numbers in standard form and converting between standard and ordinary form. As always, if you want to have a go at any of the questions in this video, grab yourselves a pen and something to write on. Standard form at this level is primarily a non-calculator topic. However, if you want to have a calculator to hand to help you out or to check your answers, you're more than welcome to do that. Standard form is a way to represent numbers using powers of 10, and the real-world application of this usually applies to very large or very small numbers. What I mean by that are very large numbers would be, for example, the one on the left. That number is 137 quintillion. So it's a very big number. You can see it's got lots of zeros at the end. And then a very small number would be a number starting with 0 point, and the more zeros we put in there at the beginning, the smaller the value becomes. Today, we will work with numbers that you are more familiar with. Think in the hundreds, thousands, 10,000s, and so on, just whilst we get comfortable learning this skill. One of the reasons we use standard form in the real world is to minimise making mistakes. When working with so many zeros, it can be easy to accidentally miss one or add one in because there are so many zeros. When we write a number in standard form, it takes this format. So we have a value A, which has to be between 1 and 10, not inclusive of 10, which means it can be 1, and it can go all the way up to 9.9 recurring, but not exactly 10. And then we always multiply that by a power of 10. Now, a power of 10 is a base of 10 written to any integer power. Integer is whole number, and that can be positive or negative. So 10 squared is a power of 10. 10 to the power of 7 is a power of 10. Even 10 to the power of 99 is a power of 10. We could have 10 to the power of negative 3. If the base or the big number is a 10 and it's written to an integer power, that is a power of 10. So we're going to do our value A times 10 to the power of something. So we will express that as a power of 10. We've got the number 13,500. And when converting this to standard form, the first thing I want you to do is look at the non-zero digits. So those are the digits that are not zero. We've got 1, 3, and 5. And just remember, we need to express that in this form where A is between 1 and 10, not inclusive of 10. So I'm going to need to put a decimal point between these digits to make that work. The only way I can put a decimal in between these digits to make it a value between 1 and 10 is if I put the decimal point after the first digit, so after the 1, making it 1.35. I couldn't do 13.5 because that's bigger than 10, and I couldn't do 135 because that's bigger than 10, and I couldn't do 0.135 because that's less than 1. So the only place I can put that decimal point is between the 1 and the 3. And then we know we're going to be multiplying it by a power of 10. The question remains, what power of 10 is it? And I've put a table of powers of 10 in just to help us out a little bit. And hopefully what you can see, 10 to the power of 1 is 10 because it's a 1 with 1 0. 10 to the power of 2, well, that would be 10 squared, or 10 times 10, which is 100. Which is a 1 with 2 zeros. 10 to the power of 3 is a 1 with 3 zeros, and so on. What would I multiply 1.35 by to get 13,500? Well, that would be 10,000. 1.35 times 10,000 would get us our 13,500. But we know in standard form, we do not want that written in this format. We want it written as a power of 10. Well, 10,000 is a 1 with 4 zeros, so that's 10 to the power of 4. So our final answer in standard form would be 1.35 times 10 to the power of 4. And some people like a quick way to help them get to the answer, and the way you can do that is to look at how many digits are there after the first. So it's not how many zeros are there, it's how many digits are after the first or after where you would have put that decimal point. In this case, it's 4. That's where that power comes from. So you write your decimal times 10 to the power of, and you can do a quick check. It's the number of digits after the first. Here are some questions for you to have a go at. Pause the video so you've got long enough to do them, and then hit play when you're ready to see the solutions. I'm going to begin by writing the digits, the non-zero digits, 2, 6, and 7, and remembering to put my decimal point after the first one to make it a value between 1 and 10. We're multiplying by a power of 10. There are 4 digits after the first, so that would be to the power of 4. All the time remembering that 10 to the power of 4 is 10,000, and 2.67 times 10,000 would give me 26,700. Our next number is 1,682,000. So my non-zero digits are these. If I put my decimal point after the first, so I get a value between 1 and 10, and I'm multiplying it by 10 to the power of, there are 6 digits after the first, so 10 to the power of 6. And again, if I carried on this pattern in my table, after 10 to the power of 3 is 1,000, 10 to the power of 4 would be 10,000, 10 to the power of 5 would be 100,000, and 10 to the power of 6 would be a million. 1.682 times a million will be 1,682,000. Sometimes they'll ask you to go the other way. So we've got this 2.45 times 10 to the power of 4. Well, we already know that 10 to the power of 4 is 10,000. 2 times 10,000 would be 20,000, so we know our answer is going to be in the tens of thousands. This would be 24,500. And once again, you can do that check. This power of 4 tells me there should be 4 digits after the first. The 4 and the 5 count as 2 of those digits, so I need 2 zeros to fill the space to get 4 digits after the first. So just a reminder, that's digits after the first, not zeros. Some people would make the mistake of just putting 4 zeros. That would be wrong. Here are 2 questions for you to have a go at. Pause the video and hit play when you're ready to see the solutions. So I've got 8.5 times, well, 10 to the power of 3 is 1,000. So that would be 8,500. And just to check, there should be 3 digits after the first. This time we've got 1.409 times by 10 to the power of 6 is a million. That would be 1,409,000. And just to check, there are 6 digits after my first. So that's very large numbers. Now we've got very small numbers. Some people think these are easier because you can just do it by counting the zeros, which, as we've seen, doesn't work with very large numbers. So once again, I'm going to write down my non-zero part of the number. So 4.61, putting the decimal point after the first digit, times by 10. And then if we look in our table here, we're looking for a way to get 3 zeros in front of the number. The way we get the 3 zeros is by multiplying by 0.001, which is the same as 10 to the power of negative 3. And some people like the quick hack for that, which is to count the zeros. There are 3 of them. And because it's a very small number, we make the power negative. So 10 to the negative 3. Here are 2 for you to have a go at. Once again, pause the video so you've got time to do them and hit play when you're ready. So if I write my non-zero digits, now let me just be careful here, because when I say non-zero digits, I'm only actually referring to the zeros at the very start or the very end of the number. Once we start counting digits, if you've got any zeros in between, they're fine. We count those as normal numbers. So we've got 3.06 times 10 to the negative 3, because we've got 3 zeros at the start of the number, so the power is negative 3. For our next one, we've got 1.8934, so 1.8934, so it's in correct standard form, times 10 to the power of, how many zeros have we got? 1, 2, 3, 4, 5, 6, to the power of negative 6. One more example, and that's to get our very small numbers from standard form back to ordinary form. Remember that negative 5 tells me there are 5 zeros at the beginning, including the one at the front of the decimal point. So 0 points, then that's 2, 3, 4, 5 zeros, followed by our digits in our value, but without the decimal point, because the decimal point is already in there. Here are 2 for you to have a go at. Pause the video and hit play when you're ready. In our first question, we have got 0.00, because it's negative 3 in the power, followed by 1056 are our digits, and we've got 9 zeros at the start of this next one, so 0.0, that's 2, 3, 4, 5, 6, 7, 8, 9, followed by our 78034. And now on to some multiple choice questions. I will put a 10-second timer on the screen for each one. However, if timers don't work for you, feel free to ignore it and just pause the video and hit play when you're ready to see each answer. We've got express 405,000 in standard form. Here are your options. And the answer to that one was D, 4.05 times 10 to the power of 5. Here is your next question. 4.921 times 10 to the power of 4, but expressed in ordinary form, so as an ordinary number. Here are your options. And the answer was B. On to the next one, express 0.000569 in standard form. Here are your options. That one was B as well, and one more, express 8.91 times 10 to the negative 9 in ordinary form. Here are your options. And the answer to that one was C. For the last section of this video lesson is your chance to do some independent practice. There are 6 questions on screen for you to have a go at. I will be popping the answers up in just a few seconds, so if you pause the video so you've got enough time to answer these and hit play when you're ready. And here are those answers. Be sure to check them carefully. Remember, if there's anything you haven't quite got right, you can go back and watch the example pairs again. Sometimes it helps to just see them once more. And if there's anything you want specific help with, please pop it down in the comments below. We do aim to answer every question relating to the content of the video. And all that's left to say is a big well done for taking part in this video lesson today. Remember that every little bit of independent study that you do will greatly benefit you when you come to sit your exams. Thank you for watching. Please remember to give the video a thumbs up and subscribe for more video lessons. And if you like short form content like quizzes and revision tips, then you can find us on TikTok and Instagram as well. I'm Charlotte. Thank you for watching this video.